Okay, good morning. Welcome to
FamilyMath number 759.
FamilyMath 759. So today we're going to talk about recursion in functions. And this is a situation where a function is defined by the numbers or the results of the function that came before it. And the most famous example of such a function is the Fibonacci numbers, where we're going to call f of n plus 1 the n plus 1 Fibonacci number. How do I find it, do you know?
Fn plus fn minus 1.
Yeah. And I have to start somewhere. There's a beginning. So I have to define the beginning ones, and I'll call f0 equals 0.
F1 equals 1.
F1 equals 1. Then let's just see what we get. What's F2 going to be?
1 also.
Okay, how did you figure that out?
0 plus 1 is 1.
Okay. F3 is
2.
2. And maybe I could just do it in a table. 0, 1, 1, 2,
3.
3,
5.
8,
5, 8.
13, all the way down.
Now that's interesting. And, you know, it doesn't totally matter a lot of things. Where you start, there's another famous sequence called the Lucas numbers. Have you ever heard of them?
No.
They have the same recurrence relation, but instead of going 1, 1, to at the beginning they go 1, 3.
Oh.
So I could redefine by calling this the 0 term and this the 1 term. Lucas 0 is 1, Lucas 1 is 3. And then what happens when I go down the list here?
It's 1, 3, 4, 7, 11, 18, 29, all the way down.
Alright, let's just double check. 1 and 3 are our beginning ones, and I get 4. Yep.
11.
7. Yeah. And 11, and then 18. Okay. Well, that's interesting. You might think, this is just kind of as an aside, I just wanted to make sure you understood what these recurrence relations mean. You might think the Lucas numbers aren't that interesting. But it is definitely a different sequence, right?
Yeah.
Yeah.
And one just kind of fun thing to show you right off the top. Let's see what happens when I multiply them. Just straight across. 1 times 1 is 1.
4.
3, 8, 21, 55. Do you recognize those numbers at all?
I think they're, well, it might be in the Fibonacci numbers.
Okay, well let's check. The Fibonacci numbers, we stopped at 8, so they're going to go 1, 1, 2, 3, 5, 8, 13, and then comes...
21, 34, 55.
And we might wonder if 8 times 18 is in the sequence. What's 8 times 18?
It's 144.
Okay.
And I believe it is.
Right. Well, what's the next one here?
It's 89, and then 144.
So when I take the product...
It looks like we're getting every other Fibonacci number.
8, 21, 55, and 144. So this sequence, the Lucas numbers, has some interesting interactions with the Fibonacci numbers.
Yep.
Okay. And this is stuff we've seen before. And I'm going to talk about how to solve these recurrence relations, which is kind of neat. But for the next video, I just want you to make up your own.
Okay.
Okay.